Hello folks, in this video I am back with one topic for class 9 ICSE following the Selina publications, and in this video we are going to discuss some numericals which are related to Vernier Caliper and screw gauge. So for the new book, that is the latest publication of Selina, you can move on to page number 22, where you will find so many numericals. Actually there are 15 numericals, and in this video we are going to discuss all these 15 numericals uh, using the whiteboard. All my other videos regarding vernier caliper and screw gauge, they are recorded over my laptop using the digital screen, but in this video I prefer to show the numericals on the whiteboard. So let's move on to the first. All those who are having the Selina book, they can open their book, page number 22. Okay, so the first question: a stopwatch has 10 divisions, graduated between 0 and 5 seconds. What is its least count? So I'll just write the page number 22 of the Selina book. And in the first question, they have said that between 0 to 5 seconds, between 0 to 5 seconds in a stopwatch, there are 10 divisions. If you see an analog stopwatch, the first mark is obviously 0 and 5 seconds. There are actually like this 10 divisions. So what is its least count? Now just revise the definition of least count. Least count means the smallest measurement that we can take using an instrument, the smallest measurement that we can take using an instrument. So we can simply write least count. You can write the full statement: least count of the stopwatch equals to, since the first is the 0 mark and the next is the fifth mark, so I'll just write 5 minus 0. In between there are 10 divisions, right? And we are talking about a stopwatch, so we can write the unit as second, and then we will get 5 by 10 seconds or 1 by 2 seconds. That is simply 0.5 seconds is the least count. Let's move on to question number 2. Question number 2 says a vernier has 10 divisions and they are equal to 9 divisions on the main scale. If the main scale is calibrated in millimeter, what is its least count? Now this sum is related to the general vernier caliper that we use in labs. So 10 divisions on the vernier scale equals to 9 divisions on main scale, and the main scale is calibrated in millimeter. These are the two simple informations that are given in this numerical. What is its least count? So you can find out the least count in two ways. First way, least count equals to value of one main scale division by number of divisions in vernier scale. So I think I'll prefer this one. They have already said that the main scale is calibrated in millimeter. I consider 1 millimeter to be the value of main scale. Number of divisions that is given is 10, because the first line that is given in the question is 10 divisions on the vernier scale coincides with the 9 divisions on the main scale. So obviously value of one main scale division is 1 millimeter, and total number of divisions in vernier scale equals to 10. So we will get as 0.1 millimeter, which is equals to 0.01 centimeter. You may cross check the answer with the with what is given in the book. We'll get it as 0.1 0.1 millimeter or 0.01 centimeter. Third one, I hope the screen is visible. I'll just cross check once. Yeah. So number 3, here a microscope is provided with a main scale graduated with 20 divisions in 1 centimeter. Very interesting, they have said 20 divisions in 1 centimeter. So since there are 20 divisions in 1 centimeter, can I write This implies that value of one main scale division. Since I have limited space here on my whiteboard, I have used the shortcut MSD, but please do not make this mistake of using such shortcuts in exams or in your class test or mock tests, because MSD doesn't actually define main scale division. It can be various things. So please do not use such shortcuts. Value of one main scale division will be 1 centimeter by 20. I'll keep it in fraction because I'm going to use it further for further, what they have asked in the question. So here, this was the information given regarding the main scale. Let's proceed further. They have said a vernier scale with 50 divisions on it, of length same as of 49 divisions on main scale. So total divisions on vernier scale I can see is 50, which coincides with 49 divisions on main scale. So find the least count. So least count here we can calculate as, if you remember the formula, value of one main scale division. So the here value of one main scale division is 1 by 20. Total number of divisions is 50, and it's since in centimeter, so 1 by 20 into 50, okay, centimeter. What we will get? 1 by 1000 centimeter, or simply we can write 0.001 centimeter. In physics, one thing we should always keep in mind, that is, never leave your answer in fractions, though it is correct for maths, but for physics, if you see the syllabus book for physics, you will find that always the numericals answer should be correct to 2 or 3 places of decimal as required in the question, but the answer should not be left in fractions. So these are the 3 numericals. We'll proceed further. I'll take a break, erase my board, and then again switch on to question number 4. So let's move on to question number 4 now. Question number 4, a boy uses vernier calipers to measure thickness of his pencil. He measures it to be 1.4 mm, and zero error is given positive 0.02 centimeter. What is the correct thickness of the pencil? So here, thickness, I'll write the question number. Thickness of the pencil is given. Thickness of the pencil is given to be 1.4 millimeter, and zero error is given as uh, positive 0.02 centimeter. We have to find the correct thickness of pencil. So therefore, correct thickness of pencil is equals to, remember the formula, observed reading minus plus minus zero error. So 1.4 mm minus, this is a positive zero error, 0.02. This is in centimeter. So obviously we need to convert this 1.4 mm to centimeter. So I can write it as 0.14 centimeter. So 0.14 centimeter minus 0.02 centimeter. How much do we get? 0.12 centimeter. This is the correct thickness of the pencil. Moving on to number 5. So number 5, they say a vernier caliper has its main scale graduated in millimeter. 10 divisions on vernier scale coincides with 9 divisions on main scale. When the two jaws are in contact, zero of the vernier scale is ahead of the zero of the main scale. Now, when we study about the zero error in vernier caliper, we will often find that the zero error is to the right of zero of the vernier scale is to the right of the main scale or to the left. But in these questions, they are saying zero of the vernier is ahead. So you may mark it, when we say ahead, it is towards the right. And whenever it is towards the right, we consider it to be a positive zero error. So the first part of the question, they are asking us the least count. So since there are 10 divisions on the Vernier scale, and it's graduated in millimeter. So least count equals 1 millimeter by total number of divisions on the Vernier scale. So total number of divisions given are 10. So I can write 0.1 millimeter or 0.01 centimeter. This is the first part of the question. Second part, they have asked find the zero error of the Vernier caliper. So since, please, you can write the statement, zero of the Vernier scale is ahead of the zero of the main scale. The error, the error is positive. The error is positive. Please note down the statement again. I am repeating, since the zero of the Vernier scale is ahead of the zero of the main scale, the error is positive. Now find the zero error. So for that it is said third division of the Vernier scale coincides with main scale division. So therefore I can write positive zero error, since the third division coincides with the main scale, positive 3 into its least count. So it will become plus 3 into 0.01 centimeter equals to plus 0.03 centimeter. I don't think any further reading is asked in this question. So we have got two answers for this one. For the first part we have the least count 0.01 centimeter, and for the next part we have the zero error, which is positive 0.03 centimeter, right? Then we will move on to number 6. The main scale is given, is calibrated in millimeter, and 19 divisions on main scale are equal to 20 divisions on Vernier scale. In measuring the diameter of a cylinder, the main scale reads 35 divisions. The main scale reads 35 divisions. So I can write main scale reading equals to 35 mm. Why 35 mm? Because 35 divisions are actually shown through the main scale, and the main scale is calibrated in millimeter. So main scale reading I am writing, main scale reading equals to 35 mm. Okay. Next, they said fourth division of the Vernier scale coincides with the main scale. Fourth division of the Vernier scale coincides with the main scale. So Vernier scale reading will be fourth division into least count. Now we did not find the least count in the first place, so we surely need to do that. Least count will be, as per the formula, since it's calibrated 1 millimeter by number of divisions in the Vernier scale. So here in the question they have said that there are 20 divisions in the Vernier scale. There are 20 divisions in the Vernier scale. So we need to take this. If I just multiply with 5 into 5, so 5 by 100, and it's in millimeter. So 0.05 millimeter. Okay, 0.05 millimeter. So now we have to calculate here. This is answer number 1. Answer number 1, as they asked us the least count. Number 2, they have asked us the radius of the cylinder. I'll erase this part. They have asked us the radius of the cylinder. So second part, before calculating the radius, we know Vernier caliper is used to find out the diameter. Okay, so we will be finding the total reading here. Total reading, that is, we know main scale reading plus Vernier scale reading, and this total reading is equals to the diameter of the cylinder. So main scale reading we got it as 35 mm, and Vernier scale reading we got fourth division, fourth into the least count. Least count is 0.05 and millimeter. Whenever we do such calculations, one thing we must keep in mind, that main scale reading, Vernier scale reading, it should be in the same unit. If you are finding the main scale in centimeters, our Vernier scale reading also should be in centimeters. So here I am getting 35 plus 0.2 millimeter. right? So we'll get 35.2 millimeter, 0.20 actually, so 0.35.2 millimeter. This is the diameter. It can also be written as 3.52 centimeter. Okay, now we have to find the radius of the cylinder. So radius equals to diameter by 2, diameter by 2. So 3.52 by 2 equals to, we can get 1.76 centimeter, equals to 1.76 centimeter. So we have our first answer, least count 0.05 millimeter. You can also write this in centimeter if it is asked in the question. And then radius is 1.76 centimeter. This is number 6. Yeah, they haven't mentioned anything in the question. Your answer should be in millimeter or centimeter, so it's your choice. Okay, I'll pause the screen for a while and erase it, and then we will move on to number 7 of the book. So number moving on to number 7. In a vernier caliper, there are 10 divisions on the vernier scale, and 1 centimeter on the main scale is divided into 10 parts. 1 centimeter is divided into 10 parts. So what will be our first thing? We need to find value of one main scale division. Why do we have to find the value of one main scale division? If in the previous sums only one statement was given that main scale is calibrated in millimeters, so we were taking the value of 1 MSD as 1 millimeter, but here it is said that there are 10 divisions or 10 parts for 1 centimeter. So obviously value of one main scale division is going to be 1 by 10 centimeter. And total number of divisions in vernier scale, total divisions on vernier scale is given as, I think it's given as 10 divisions, 10. Okay, so first, before we proceed with the sum, we should always find out the least count, because we know whatever we need to calculate, least count will be needed. So value of 1 MSD is 1 by 10, and total number of division is 10, and it is in centimeters. So 1 by 100 centimeter, or we will get 0.01 centimeter, right? Now, while measuring a length, 0 of vernier just lies ahead of 1.8 centimeter mark, and fourth division of the vernier coincides with the main scale. So while measuring the length, they have already given us the main scale reading. Main scale reading they have given us to be 1.8 centimeter, and vernier scale reading we need to find out, because here for vernier scale reading they will tell us the division which is coinciding with the main scale. So here in the question they have given fourth division, and we need to multiply it with the least count. Please check, main scale reading is in centimeter, vernier scale reading is also in centimeters. So it will be 0.04 centimeters. Now, as for the first part of the question, we can calculate the length or the total reading. So total reading will be 1.8 plus 0.04 centimeter. I can simply write 1.84 centimeter. So length is 1.84 centimeter. Please see number B. For number B, they have said zero error is given as negative. They have given us zero error, negative 0.02 centimeter. Okay. So what is the correct length? Correct length will be 1.84 minus, here obviously, so every time correct reading or total reading is equals to observed reading minus negative plus minus zero error. So plus minus zero error, since we have got a negative zero error, 1.84 minus 0.02, please see here it becomes positive. So positive 0.02 centimeter. How much we will get? 1.86 centimeter as the correct length. because the zero error is negative. So this was number 7. Number 7, part A, we have calculated the correct length to be 1.84 centimeter, and after the zero error the correct length is 1.86 centimeter. I'll erase the board and we'll move on to number 8. So number 8 now. Number 8, there is a diagram given. I'll not draw the diagram on the board, but you can refer to the book. And they have just asked us the length of the rod. So length of the rod. Now here I can see that the zero mark of the vernier scale has crossed, and the main scale, please see, it is in centimeters. They have crossed 3, then 3.1, 2, 3, 3.3. They have crossed 3.3 centimeters. So I'm just writing main scale reading. Please write in full form 3.3 centimeter. You can cross check the diagram from your book. And then which division of the vernier scale coincides with the main scale? As I can see, before going to the calculating the vernier scale, we need to find the least count. So least count, here I can see the entire main scale is calibrated in centimeters, and so I can say that value of one main scale is going to be 0.1 centimeter. And how many divisions are in the vernier scale? Here, as per the diagram, there are 10 divisions. So I can write 0.01 centimeter is the least count. Now let's move on to the vernier scale reading. For finding the vernier scale reading, we have to find which division is coinciding with the main scale. Which division is coinciding with the main scale? So as per the question, as per the question, 3 point as per the question, I think which division is coinciding. um, I can say sixth division is coinciding. Sixth division is coinciding with the main scale. So we can write as 6 into 0.01 centimeter, or we can get it as 0.06 centimeter. So therefore total reading is 3.3 plus 0.06 centimeter. We will get it as 3.36 centimeter. This is it for number 8. Let's move on to number 9 now. Now the numericals are related to screw gauge. Pitch of a screw gauge is given 0.5 millimeter and number of circular scale divisions are 100. Find the least count. So least count, we can directly write pitch by number of divisions in the circular scale. Number of divisions in circular scale. So pitch is given here as 0.5 millimeter and number of divisions are given as 100 because the circular scale is divided into 100 equal parts. So 0.0005 millimeter, which can also be written as 0.0005 centimeter. So this is the least count of the screw gauge. Okay. Number 10. Number 10. Pitch is given 1 millimeter, circular scale is given 100 divisions. So the first part of the question, they have asked us again the least count. Pitch is given as 1 millimeter, number of divisions they have, sorry, did I read the wrong question? Yeah, I read the wrong question. Sorry, I just moved out to number 11 instead of number 10. Number 10, thimble of a screw gauge has 50 divisions. Thimble of a screw gauge has 50 divisions. So there are 50 divisions in the circular scale. And the spindle advances 1 millimeter when the screw is turned through 2 revolutions. So first part of the question, they have asked us the pitch. They have asked us the pitch. Remember, pitch means the linear distance moved by the main scale on rotation, on one rotation uh, of the thimble. So here on two revolutions, they have said that the main scale advances sorry, the spindle advances 1 millimeter on 2 revolutions. So pitch will be 1 millimeter by 2. I can write it as 0.5 millimeter goes to 0.05 centimeter, right? So 10 part 1, I hope now I have read the correct question, 0.5 millimeter or 0.05 centimeter. Next they are asking us the least count. So least count is pitch by number of divisions in the circular scale. So pitch we have already got 0.5 millimeter. How many divisions are there in the circular scale? As per the questions, there are 50 divisions. There are 50 divisions. So we can write it as 5 by 500 millimeter, or 1 by 100 we can make it easily, right? 1 by 100. So 0, 0.0 uh, 0.01 millimeter equals to 0.001 centimeter. So let's check it. 10 part 2, we have got 0.01 millimeter or 0.01 centimeter. So this was it for number 10. We will move on to number 11. Number 11, as I was reading previously, pitch is given 1 millimeter, circular scale has got 100 divisions. So first part is least count. Pitch is given 1 millimeter and number of divisions are 100. So I can write 0.01 millimeter equals to 0.001 centimeter. Let's move on to the second part. In measurement of the diameter, main scale reads 2 millimeter. So main scale reading 2 millimeter. Now we have to find the circular scale reading. For circular scale reading, which division of the main scale, which division of the main scale coincides with the baseline of the circular scale? So here it is said 45th mark. 45th mark. So 45 into, since it is in mm, I am going to use the least count 0.1, sorry, 0.1 millimeter. So I can write it as 0.45 millimeter, right? Now they are asking us the diameter of the wire. So total reading equals diameter of the wire. In case they would have asked the radius, then also we would have to find this one, then divide it by 2. So main scale reading 2 plus 0.45, I get it as 2.45 millimeter, or I can leave my answer as 0.245 centimeter. So this is it for number 11. We will move on to number 12. Number 12. When a screw gauge of least count 0.01 millimeter is used to measure the diameter, reading on the sleeve is found to be 1 millimeter and reading on the thimble is found to be 27 divisions. Remember, sleeve gives us the main scale reading because it holds the male scale, and the thimble actually has got the circular scale. So least count they have already given here, 0.01 millimeter, right? 0.01 millimeter. Now the main scale reading is given as 1 millimeter, and we will calculate the circular scale reading. How many divisions are given? Number 12, yeah, number 12, 27 divisions. The thimble is found to be 27 divisions. So 27 into its least count, I can write this as 0.27 millimeter, right? Now the first part of the question, what is the diameter of the wire in centimeter? So diameter in centimeter they have asked. Diameter of the wire, you can write the total reading 1 plus 0.27 millimeter, 1.27 millimeter. Since they have said the answer should be in centimeters, So 0.127 centimeters, 0.127 centimeters. This was very easy. Second part of the question also they have given us zero error. So zero error is positive. Zero error given is positive 0.005 centimeter. I hope this is the mark value. Yeah. So therefore correct diameter is going to be 0.127 centimeter minus then 0.005 centimeter. So we'll get it as 0.122 centimeter, right? So 12 part to 0.122 centimeter. This is it for number 12. We have 13, 14 and 15 left. Okay, so let's move on to number 13. Number 13 on your screen, on the board actually. Screw gauge has 50 divisions on its circular scale. Screw moves by 1 millimeter on two rotations. On two rotations. So value of the pitch linear distance moved in one rotation. So in two rotations it is moving as 1 millimeter. So I can write 1 millimeter by 2 because two rotations are given. So I can write this as 0.5 millimeter. Let the statement means let the value be in millimeter right now. Later on we will see. 50 divisions are there in the circular scale. So this is answer number 1. This is answer number 1 because the first part of the question they have asked us the pitch. Second part, they are asking us the least count. So least count equals to the value of the pitch by total number of divisions in the circular scale. So circular scale has got 50 divisions. So I can write it as 5 by 500. It has to be in millimeter, right? So 1 by 100, or I can write it as 0.01 millimeter. So this is the least count. Okay, next third part they have asked the zero error of the screw gauge. So for finding the zero error, let's move on to the statement part. When the flat end of the screw is in contact with the stud, zero of the circular scale lies below the baseline. So when the zero is lying below the baseline, fourth division is coinciding with the baseline. So fourth division, since it's coinciding with the baseline and zero is below the baseline, we can say that the error is positive. Error is positive. So therefore, positive zero error. They have asked us only to find the value of the positive zero error. So positive fourth division is coinciding into the least count 0.01 millimeter. We'll get it as positive 0.04 millimeter, 0.04 millimeter, and that has to be a positive sign as well. So this is it for number 13. Number 14, as I can see on the book, there is a diagram given, and please see the diagram from the book itself. Questions in this Selina book are very easy. So number 13, uh, first statement that's given is screw advances by one division on main scale when the circular head is rotated once. Okay, so and the main scale is calibrated in millimeter. The main scale is calibrated in millimeter. So I can write first as the pitch of the screw gauge. Pitch of the screw gauge means the linear distance moved by the screw on one rotation. So there in the question itself they have said screw advances by one division on main scale when the circular headed rotated once. So I can write is 1 millimeter. Why? Because that's the advancement, one division on the main scale. Main scale is calibrated in millimeter as per the question given in the book. So pitch is 1 millimeter. Next we have to find the least count of the screw gauge. To find the least count of the screw gauge, it has to be pitch by number of divisions on the circular scale. How many divisions are given? As I can see on the book, there are given 50 divisions. Okay, there are given 50 divisions. So I can make it as 2 by 100 or 0.02 millimeter. So least count is 0.02 uh, millimeter, right? And next is the diameter of the wire. So for finding the diameter, we need to find the main scale reading, we need to find the circular scale reading. There is no information given regarding the zero error, so we are going to skip that, or we are going to assume there is no zero error. Okay, so diameter of the wire here is equals to main scale reading plus Vernier scale read, sorry, it's the circular scale reading here. So main scale reading, as we can see from the book, 0.2, so 1 2 3 4 4 millimeter, 4 divisions are there, so 4 millimeter. And circular scale reading, we have to find the mark of the circular scale which coincides with the baseline. So 45, 46, 47 I can see. So 47th division into the least count, 47th division into the least count. So 4 plus, I think we will get here as 47 into 2, 9, 94, 94. So 0.94 millimeter, or we are getting it as 4.94 millimeter. Now here in the question they haven't asked anything that the answer has to be in centimeter or millimeter, so I'll leave the sum here itself. This is it for number 14, the last one. Now screw has a pitch of equal to 0.5 millimeter. What should be the number of divisions so as to read correct up to 0.01 millimeter with its help? So least count here is given. They have given us the least count 0.001 millimeter. They have given us the pitch 0.5 millimeter, and they are asking the number of divisions on the circular scale. So we know the formula, least count equals to pitch by number of divisions on circular scale. So from this formula, can we write number of divisions equals to pitch by least count? What is the pitch given? 0.5 millimeter. Pitch is given 0.5 millimeter and least count is given 0.001 millimeter. Please see, the units have to be same, and since this is the ratio of two similar units, our answer will have no unit. Simply we need to calculate. I can write this as 5000, because considering the three places of decimal in the denominator and the numerator has got one place of decimal, so it becomes 10. So 500 is the answer. So the number of divisions in this sum that's asked in the question is 500. I hope all these 15 numericals are clear, and since I'm using a wireless microphone, I hope my sound is clear as well, and no background reduction is there. I'll cross check while I slightly edit the video, but I'm going to upload it mostly the raw one. So if you are having any doubt, please take the help of the comment section and let me know. Thank you.